What's up, guys? Mr. Patterson here with another video for IB Math AAHL. Still talking about vectors. In this section, we're talking about parallelism. We're going to be talking about parallel vectors. We're going to talk about collinear, and we're going to talk about skew vectors and what the difference is and how we identify it in different formats. So the first thing is we want to figure out what parallel means when we talk about vectors. And it kind of means the same thing when we talked about lines. So basically, if we're going in the same direction, then we're going to be parallel, as long as they're not the actual same vector, because if they were the same vector, then they would be collinear, okay? So it says here, two non-zero vectors are parallel if and only if one is a scalar multiple of the other. So basically, if we take one vector and we can multiply it by some scalar value, and we get that other vector, then those two vectors are parallel. So if we look at this example here, it says find R and S given that vector A, which has the component form of 2, negative 1, R, is parallel to vector B, which has the component form S2, negative 3. So if we look at the y components, we have negative 1 in vector A and 2 in vector B. So what would that scalar multiple be to go from vector A to vector B? Clearly, we're multiplying by negative 2. So if I want to take this x coordinate or component 2 and multiply by negative 2, that should give me an s value of negative 4. Similarly, if I take r and multiply it by negative 2, I should end up getting negative 3. And if I were to try to solve for r, I could just divide by that negative 2 and get 3 halves. And that's exactly what we see here. We find that k value of negative 1 half. Now, this is obviously showing it from the opposite perspective. Vector A equals k times vector B. But the k could really be on either side. It doesn't really matter because it's still going to be a scalar multiple. Let's talk about unit vectors for a second. We talked about unit vectors before. The general idea is that the magnitude is going to be 1. So if we understand which direction a vector is going in, we can then find the unit vector that corresponds to that particular vector there. So it says a unit vector in the direction of vector A is, and we see this vector A with a hat over top of it, is equal to 1 over the magnitude of A times vector A. So basically what we're doing is we're finding what that magnitude is, and then we're going to multiply each component of vector A times 1 over that value there. All right. Then it says vector B of length k is in the same direction as vector A, is vector B equals k times the unit vector of A, which is the same as k over the magnitude of vector A times vector A. So let's take a look at an example here. It says find a vector B of length 7 units in the opposite direction of vector A, which is 2, negative 1, 1. So we have a couple things going on here. We know that it's going to be a magnitude of 7, but we also know it's going to go in the opposite direction. So the first thing we're going to do is we're going to take that 2, negative 1, 1, and we're going to multiply it by 1 over the magnitude of vector A, which is the square root of 2 squared, 4, negative 1 squared, 1, 1 squared, 1. So that's going to give us 1 over root 6 times that vector A. But since we want it to go in the opposite direction, we're going to multiply it by a negative in front. And we want it to be 7 units long, so it's really negative 7 over root 6 times that vector A that we previously had there. So there's a lot of things going on in this particular problem. Make sure you stop, look at it, and make sure it makes sense to you before you move on. All right, let's talk about collinear points. Okay, collinear just means we have points that are on the same line. Pretty much makes sense there. So the general idea here is that if I were to take any two of these three vectors, I would get that we would have the same direction. In other words, the vectors would be multiples of each other there. So that's why we see vector AB is equal to some scalar multiple k times vector BC. All right. So here it says prove that A, B, and C are collinear. So in order to do that, we're going to find vector AB, we're going to find vector BC, and to get vector AB, we're just subtracting the points that are on point B minus the points from A. That's where we get the 5, -2, -4. And do the same thing for BC. We get 10, -4, -8. And we notice that those are clearly connected to each other. Specifically, if I were to multiply the points in vector AB by 2, I end up getting vector BC. Therefore, since they are scalar multiples of each other, A, B, and C are collinear. That's it for this section. Make sure you guys do some of these practice problems here on page 297, numbers 1 through 15 odd. And if you have any questions with it, let me know. I can go over and make a separate video or just kind of show you my work for it. Have a great day, and I'll talk to you guys soon.